morning, everyone, and welcome to API Days Australia. Today, we have a really interesting speaker coming to talk to us all the way from San Francisco. He's a senior software engineer at a firm we all know and love, Netflix. He describes himself as a conference speaker, technical writer, open source lover, and contributor. One of the lines he's written in one of his blogs is, "I deploy to production from airplanes." That is so super cool. He's written a large number of blogs, which range from how to automate generating new Rails applications to being ready for change with hexagonal architecture. Damir spoke at the Hong Kong API Days in August and now joins us in Australia. I'm looking forward to hearing him speak on designing APIs. Just enough is perfect. Please welcome to the stage, Damir Svrtan. Damir, the stage is yours.
Thank you. Thank you so much. Hi, folks. So the title of my talk today is going to be Designing APIs, Less Data is More. I'm super glad I could present to you all today. I'm sad that we're not all together at a nice location in Australia where we could all meet up and hang out. But at the same time, it's great that we could all join this conference from across the globe. Let me introduce myself. So my name is Damir Svrtan. My pronouns are he, him, and I work as a senior software engineer at Netflix, where I build applications that power the biggest studio in the world. I'm based in San Francisco, and that's where I moved about 3 years ago. Prior to moving to San Francisco, I used to live in Zagreb, the capital city of Croatia, a small country in southeastern Europe. That's where I grew up and where I spent the first 28 years of my life. Now, designing APIs, less data is more. Why is this topic relevant to me? Well, I've been building APIs for the last 7 years, and I've seen a pattern where developers like to expose more data than is actually needed. I want to talk about avoiding overhead when designing APIs. Now, what kind of overhead am I talking about? I'm talking about bloated, overly flexible APIs. APIs that have queries that nobody asked for, endpoints that nobody's using, generally unused functionality like extra fields, extra relationships, all of these things that you have to maintain, but nobody's actually using them. Now, what kind of APIs am I talking about? Well, it's mostly HTTP-based APIs, REST APIs, JSON APIs, and GraphQL. But this talk is going to be API technology agnostic. It's going to be applicable for all kinds of APIs. Throughout this talk, we're going to be building a blogging platform, something similar to Medium or Dev2. Now, this blogging platform will have a couple of relationships between itself. So it will have authors that can release posts, and it will have posts that can have comments. Fairly simple blogging platform. I'm going to talk through this talk through a lens of two principles for building APIs. The first one being designing the minimal API surface, or how not to overexpose data on your APIs. And the second one, designing from strict to loose, or how to avoid building extra flexibility that nobody asked for. So the first principle, designing the minimal API surface. Generally, I see a pattern where developers try to be speculative about what's going to be needed in the future. So they often overbuild their APIs. I'm going to break this into three patterns of a bloated API surface that I usually see. The first one being redundant fields, the second one, redundant relationships, and the last one, redundant input fields. So let's start off with the first one. Don't expose redundant fields. So let's imagine we're building this blogging platform. We have a product manager that asks us, can we show the author of the blog post next to each blog post? So this is just a screenshot from medium.com. Should probably be familiar to a lot of folks. Now, let's imagine we have some kind of a database table. Doesn't really matter what kind of a database it is, but it has a couple of attributes. It has an ID, it has a first name, a last name, an email, and an avatar URL. If we look at the designs that we got, we can see there's an avatar, so we might need to use the avatar URL, right? We have a first name, a last name. We might use the ID for some kind of client-side caching, but there is no email that is shown here, right? Well, let's imagine there's a friendly API developer that really wants to help its consumers, and the friendly API developer says, let's expose the email. Someone might find it useful in the future. Why wouldn't we expose the email field right away? We're going to spend more time exposing it if we need it afterwards, right? So we're technically saving time for the business. And now let's imagine we have some kind of a schema descriptor, schema language that we're, documenting our API in, and we have an author type. And with all of these fields that are going to be useful, we add the email field in. Now let's imagine a scenario 6 months later. For privacy reasons, we might need to stop exposing the email. Now, I'm not making these things up. These things happen. Europe has GDPR laws. California has privacy laws. A bunch of countries in general and areas of the world have privacy laws that dictate that you shouldn't be storing or exposing data that is not critical, or storing personal identifiable information that is not relevant to the business. So we need to stop exposing the email. And what did we just get with that? Now we got to go through a deprecation cycle. We got to mark the field as deprecated if our API descriptors allow that. Or if it's a versioned API, we might need to release a new API version. And then we have to go through extreme amounts of communication. We have to send out emails, reach out to clients. If we're building an API platform, that can be really hard. So we got to give a few months of lead time, and we might have tens or hundreds of thousands of API consumers. Now, if we have a private API, that's a smaller amount of clients, but it's a lot of communication nevertheless. And then we're potentially breaking clients. Now, if our APIs support something like field selections or sparse field sets, like in JSON API, where a client can specify when they're requesting an author exactly which fields they want, we might be lucky to understand whether folks are actually using this. But if we don't have any sparse field sets, we have no idea whether we're actually breaking clients. Whenever they're asking for an author, they get all the fields back. And then we got to go through extreme amounts of redundant cycles. We got to go through multiple deploys. We got to deploy our code into production that states that a field is deprecated. And then once we actually want to remove the field, we probably want to deploy it to some kind of testing or staging environment, check out whether everything's working fine. And then the real test goes on once we deploy it to production and potentially break clients. So it's not just as easy as removing a few lines of code. Actually, it's like the technical part of it is pretty simple. You just remove the code. But the actual organizational and coordination challenges that come with this are the part where we spend a lot of time. Now, the second part that I want to talk about is not exposing redundant relationships, which is pretty similar to redundant fields. Let's imagine we have a requirement where we need to indicate whether a post was reviewed. So let's imagine we have like a feature that has a group of reviewers that can review blog posts, and if they've reviewed it and think it's academically or scientifically its research was good, we add a green check mark next to the post title. Now let's imagine in our schema descriptors we have a typed post that has a title and a body. Now we need to add a reviewed boolean to indicate whether our UI is supposed to show the green check mark or not. Well, now the friendly API developer from before might now say again, well, let's expose the reviewer for future use cases. Somebody just might need it, and we won't need to build it out again later. So all of a sudden, besides the reviewed field, we add a reviewer, and we potentially need to add a new type called reviewer. Now, what did we get with this? The development costs are growing. We potentially, because it's probably a different relationship, we need to batch or eager load the reviewers. We need to test out whether it's loading and showing properly. And then we potentially might have performance impacts. Again, if we have some way to select fields where clients can pick and choose the fields they want to use, maybe we're in a better off position than if whenever they ask for a post, they always get a reviewer, because that way we're already increasing, the latency or the response time that we're, handing off the responses to our clients. And now, what if, let's say, a year after our product managers decide, well, let's not have one reviewer, let's actually have multiple reviewers, and let's actually show their avatars next to the post title. So now we got to go through a deprecation cycle. A lot of communication, emails, Slack messages, whatever you have. And then we're potentially breaking clients. But there's one more thing that is very important that we're not utilizing, and that's delaying decisions. Because adding later when we have more knowledge is actually better. Like if we, a year after now, decide to add that feature, decide to expose the reviewers, we'll have more knowledge of the system than we have it now. Like we might not call the type reviewer, we might just call them users or authors or something else, but we're not leveraging this with exposing unnecessary data at the beginning. In general, it's easier to add in the future than to remove. I've been through this many times where I was removing stuff that nobody asked for, and I guarantee it's way easier to add in the future than it is to remove. Sometimes additions to the API can be done within an hour, while removals take a lot of time. Okay, so that's about exposing fields on queryable resources. Let's talk about not exposing redundant input fields. Now, what kind of input fields am I talking about here? Well, I'm talking about the payload your API accepts when you're mutating or changing data. In REST APIs, that would be the data your API gets whenever a client initiates a post or a put request. Or in GraphQL, that just might be the data that your mutation takes in. So let's look at an example. Let's imagine we have a requirement where readers need to be able to create and update comments. Now we have an input called create comment that accepts a post ID, so we know to which post we're attaching this comment, and it accepts a body, which actually shows the comment, right? Now, the friendly API developer might say, let's have parity between these inputs. So let's build the update comment with an ID of the comment itself, with the body, and with the post ID as well. Well, all that you need is an ID and a body. Why would you need a post ID? Would you ever change the post ID on a comment? Very unlikely. The blogging platform that we're building probably doesn't support comment transitions from one post to another. Could you imagine that, your product managers, as you're building a blogging platform, actually productize something like this, where if you've commented on one blog post and decided, oh, no, it's, I commented on the wrong blog post, that you actually have an ability to transition that comment? No, what you'd probably do is like copy that text, delete the comment, and then go to the correct blog post and post it there. So there's really no reason to expose something like this. So we only need an ID and a body. So I would say avoid anemic data modeling. Sure, the create comment input has a post ID. Even the comment resource probably has a post ID, but it doesn't mean we're able to actually update it, right? These do not have to match. You're supposed to build your apps according to your business needs, and that business logic should be on the server, not on the client. There's a really excellent blog post that I would recommend you to read. It's from Mark from GitHub, and it's called GraphQL Mutation Design, Anemic Mutations, where he takes a deeper dive into problems like this. And then I would say ambiguity like this deteriorates the developer experience. Our clients might get confused. They may think, what happens if I send the same value? What happens if I send a different value? And what do we do on a server if the same value is sent? Okay, we just let it pass. But what if they send a different value? Do we stop it there? Do we, raise an error, return some errors or something like that? Why would we even try to build this? And then lastly, you ain't gonna need it, don't put it in. Simple as that. Okay. Now, I want to talk about the second principle that I mentioned in this talk, and that's strict to loose. And I'm going to break it into two parts again. So the first part being avoiding extra flexibility, and the second one, breaks first. Avoiding extra flexibility, I'd say when you're building an API, you need to be ready for extra flexibility in the future, but not extremely flexible now. You need to scope out what is needed for your clients and build just that. So let's imagine we have a requirement. The users need to be able to see comments on a post. Now, let's imagine we have a comments query in GraphQL or comments kind of endpoint in REST or whatever. We have some way to get comments. And kind of the thing that would be led by intuition is to add a post ID and make it required so that the clients always need to send the post ID. Well, now our friendly API developer back again might say, well, our clients might want to fetch all comments in the future. Let's just enable them not to send that post ID. So what the friendly API developer would do was to make the post ID optional. Okay, now what did we get with this? Well, first of all, we got unneeded application logic. We need to handle both cases, if there is a post ID and if there is not a post ID. In general, more code means more maintenance. Anytime you change something with the commenting logic, you need to reflect that in both scenarios. And then caching. Do we have two strategies, one for when there isn't a post ID and one for when it is? I don't know. It seems fairly complicated for something that is really not needed. And then more code means more tests, because you got to test out both cases. So you're already spending much more time for something that is really not needed in your application. So in inputs, I would say it's easy to go from required to optional, but not the other way around. Strict to loose or required to optional gives you more control. It gives the client less flexibility, but it's not the flexibility that they have asked for. But it gives you more flexibility in terms of changing. While loose to strict or optional to required is a breaking change. If all of a sudden we change that input to be required, whoever it was sending it as optional or not sending it would break those clients. Okay, and now to the second part of the second principle, and that's breaks first. Now, I want to talk here about defensive programming and ensuring that your API is not going to get abused. Let's go with the same example. Let's imagine we have a requirement. It's called, that is the same as before, ability to fetch comments for a post. Now, the friendly API developer might say, let's just give them an array of comments. We don't need pagination. Or even a better version of this, we don't need pagination yet. Now, we build this query or endpoint that always returns an array of comments. Now, the friendly API developer's reasoning might be, well, we won't have more than 5 comments per post. Well, guess what happens in a lot of scenarios? And this, I'm guilty of this as well. 6 months later, a year later, who knows when, there might be posts with hundreds of comments. So now we're, suffering some performance penalties on both of our API and on our UIs. Now, the developer might say, now, let's add pagination now. Well, we add some kind of paginated comments, really not, really doesn't matter what kind of paginated comments. And now all of a sudden, that's either a breaking change or we're introducing a new query or a new endpoint. And now we got to migrate all of those clients. So we're actually now incurring a bunch of overhead as well. Now, the API developer might say, work is done. Let's go home. Fairly simple and easy. Well, not so soon. What if one of our clients actually uses the query like this, where they send, where they ask for the first 1,000 of comments? Maybe the client was just too lazy to do paginated requests. Now, what happened? Well, the friendly API developer didn't add limits to pagination. Adding pagination limitations from the beginning is the way to go. It's super hard to add it retroactively. You can add it at the beginning, and you can answer with an error message when somebody's requesting too many saying something like, requesting 1,000 records exceeds the limits of 100 records that we're ready to give you. It's super hard to add these things retroactively, but it's super easy to adjust in the future. Like if you didn't have any pagination limits and then you add them retroactively, that's a breaking change. Or if you added a super high number and you need to lower it down, again, a breaking change. But if you start, pushing the number up, and if you started with a really low number, it's easy to adjust it in the future. Okay, now how to avoid these overheads? I would say adopt schema first design. Figure out what is your domain and for whom you're building your API. Don't try to play guessing games. Don't couple your API to specific implementations. Maybe today you have a relational database that is backing some of this data. Tomorrow, it might be some API that won't have the same fields, and you might bring yourself more trouble than anything. And then talk to your clients. Involve them early in the process. Figure out what their needs are. Don't try to be speculative. And be responsive to your clients' requests. As you're building out a minimal schema that is not overbloated, you have to be responsive to future requests. Now, there's always exceptions to these guidelines. A few that I can think of is, first one being, if you're building a platform API, there might be a little bit of speculation here if you're building a platform and trying to get ahead of competitors and you're trying to drive user adoption. But even then, I would question how much this kind of speculation is actually worth it. And then the second one might be constraints due to release cycles. Now, I have a coworker that worked on APIs that were deployed on premises for their clients. They would release these once every 6 months, and they would have to do thousands of deployments every time they released it. If they missed a field that a client might need, they would need to have to repeat the same redeployments, which would be extremely costly. Now, this is a very unique situation, and you're probably not in it. So if you're deploying multiple times a day or multiple times a week or something along those lines, there's really no reason to try to play guessing games. In conclusion, what I would say, redundant work like this slows down progress on important features. You might be able to spend your time more wisely by improving API documentation, improving slow queries, and so on. Exposing too much data can be actually highly unproductive. There is a saying, the road to hell is paved with good intentions. Even though we might think we're doing something good for our API clients and being a good partner, that often is not the case with these things. That's all, folks. Thank you so much for listening. If you want to talk more about this topic, let's talk afterwards, or reach out to me on Twitter. Here's my Twitter handle, or add me on LinkedIn. Just search by my name. Thank you so much.
Thank you so much, Damien. That was really interesting. We've had a couple of questions come through. So the first one I'd like to ask is one around, someone said they liked your comment, it's easier to add in the future than to remove, but for some things where there's a future requirement that might be a breaking change, it makes more sense to include it up front. For example, make something mandatory versus optional. Do you have any guidelines around what kind of security controls you'd include up front?
Security controls in terms of in general when building APIs, or I'm not sure I understood the question.
I think in general around, what kind of security you'd build in.
Well, if it's security in terms of like if we might need something in the future, but we don't need it now and we want to build it now, I would say, you can always put it behind some kind of feature flags or something like that, or something that, feature flags that only certain amount of people can actually, leverage. But I would actually recommend against like trying to build out additional stuff too far in advance, because if we're building things too far in advance, a lot of things might change. Software changes, our requirements change. So if we try to build something that's going to be used only in like 6 months from now or something like that, oftentimes we actually might need to tweak it a lot or just even completely change it. So I would say, try to build it timely and not try to, guess how it's supposed to be used in the future.
That's a great answer. Thank you, Damir. And then one other as well is around someone saying if they've inherited an application and the APIs are already fairly complex, what would you recommend they do to change that to be more supportable and simpler?
Yeah, I would definitely recommend, first of all, having observability around how your API works, having some kind of metrics where you can understand which parts of the API are actually getting used. And, start off by figuring out which portions are not used and removing them, removing them in a safe manner. It's always risky to remove stuff because if you're not, careful or you miss something, and even, with the best intentions, you might miss something. So, try to, really make sure that things are not used and start getting rid of them. And as you're removing these APIs, try to remove the code that is connected to them. Like if it's, if there's some specific parts of the code base that have only been leveraged on these API endpoints that are not used, delete that as well as soon as possible.
Apologies. These are the tricks from being at home. I had a small introduction. And Damir, another question to you really is more around, for you, what has life been like for you in the last months of, you've been presenting at conferences all over the world, but yet you've done that without leaving home. What is it like presenting remotely versus what it was like a couple of years ago?
Yeah, I would say this is definitely not ideal. Like in terms of I like presenting at conferences, but I like mostly because I get to meet a lot of people. I get to travel, hear other people's experiences. While, this way, I managed to, meet some people over Twitter or LinkedIn or stuff like that, or in the conference chat. But it seems like it's very unidirectional, I just presented a talk, and if my internet went down, I might have not have noticed that my internet went down at all, so it's not really comparable. I really wished if, I was able to fly to Australia and give this talk in person, but hopefully I don't want to speculate whether that's going to be next year or whenever, but I really hope that does come soon.
Well, Damir, we hope that too, and we'd love to welcome you into Australia. But yeah, until then, thank you so much for your time today. That was fascinating. We've loved having you here. Thank you.
So much.